Hello children, I welcome you all. We are in Gedara now to learn Unit 28 in your mathematics. It's about construction. In this construction lesson, you will be able to learn three things: construction of loci, construction of triangles, construction of parallel lines. Today, I am going to discuss with you how to construct loci. Especially, get ready with your pair of compasses, ruler and pencil. Make sure to sharpen your pencil to get accurate construction. Get ready with me. Before going to construct loci, let's see what is locus or loci. Locus is the singular word for loci. Locus is a path. There are so many paths in our environment. Hope you have seen ants moving. That is also a path, but we can't say that is a locus in mathematics. Locus is a special path. What is a locus? Locus is a path. Locus is a path of a point moving according to geometrical law. Let's see some examples. A path of a planet orbiting around the sun. A path of a ball that thrown upwards. The path of a ball that hit by the bat. The path of a pointed end of a clock hand. These are loci. In mathematics lesson, we will only consider loci in plane figures. Let's define locus. The path of a point in motion according to geometrical law. It is a path of a point in motion, that path of a point in moving, the path of a point in motion according to a geometrical law is defined as locus. In this lesson, we identify four basic loci. Before going to consider loci, let's see some geometrical facts. Distance between 2 points. What can we call distance between 2 points? Let's see children. A and B are 2 points. Distance between 2 points. What is this children? This is a line segment. Distance between 2 points we call line segment. Distance between from point to a line, that is not just a line, that is the shortest distance. Distance between point to a line, that is the shortest distance, that is the perpendicular line. Distance from a point to a straight line, what is it children? That is a perpendicular line. Distance between two parallel lines. Distance between two parallel lines, that is not just a line. Let's take A on any point. Distance between two parallel lines, this is the shortest distance between two parallel lines. We call that is also perpendicular line between two parallel lines. Okay children, now let's learn four basic loci. Before going to learn four basic loci, we should know what are these basic loci. Today, I am going to discuss with you four basic loci. The first one, constructing the locus of a point moving at a constant distance from a fixed point. Let's see what this is. Let's take an example. Look at these clock hands. Tip of a clock hands moving constant distance from a fixed point. Let's take fixed point as O, constant distance, a point moving. What is this? It is a circle. Locus of a point moving, constant distance from a fixed point. Constant distance from a fixed point. So, what is this, children? This is a circle. So, the fixed point is the center. This constant distance is the radius. So, the point moving, that path, that locus we called circle. Circle. The locus of a point moving at a constant distance from a fixed point is a circle. Let's construct circle. Get ready with your pair of compasses, pencil and a ruler. Check whether your pencil sharpened. The pointed end of the pair of compasses and the pencil both in the same level. Let's start it. The fixed point I have marked as O. You also can try. Marked as O. Let's construct a circle with the radius 4 cm. Take the help of ruler. Measure 4 cm. Keep the steel point on O and move your pencil. Pointed edge of the pencil moves on a circle. Locus of a point moving at a constant distance from a fixed point is a circle. Fixed point is O, radius is 4 cm. So, this is a circle. Let's construct the second locus. Constructing the locus of a point moving at an equal distance from two fixed points. What is this? Let's see what this is. A and B are two fixed points. Locus of a point moving at a constant distance from two fixed points, A and B. Let's join this AB and let's find the locus. Here you can see each and every point equidistant to A and B. Let's take any point as P. AP is equal to BP. So, what is this, children? That is the perpendicular bisector. Perpendicular bisector. Perpendicular bisector. The locus of a point moving at an equal distance from two fixed points is the perpendicular bisector. Now, let's construct perpendicular bisector. You have to work with me. Mark 2 points as A and B. Just as earlier, join A and B. Now, take pair of compasses. Keep the steel point on A. You can take radius more than the half of AB. Draw an arc on both sides. Don't change the radius, draw an arc on the other side. Next, keep the steel point on B, jump to B. Don't change the radius. Draw an arc to intersect the two arcs. Here we found a point. Two arcs intersect at a point. Here we found the second point. Now let's see, let's join that 2 points. Take the help of a ruler, you can join that 2 points. So how do I know that it's a perpendicular bisector? Bisecting, you have to mark equal, perpendicular. So this is the perpendicular bisector of AB. Okay, let's learn the third locus. Constructing the locus of a point moving at a constant distance from a straight line. What is this? Let's see what is this. Each and every point moving equal distance to AB straight line. Not only one path, there are two. So what is this? That is a parallel line, not only one parallel line, two parallel lines. Locus of a point moving at a constant distance from a given straight line is a parallel line. Not only parallel line, two parallel lines lie on either side of straight lines. Let's construct parallel line. To construct parallel line, we need two perpendiculars. You can draw perpendicular to this AB, not only one perpendicular line, two perpendicular lines to AB. So I selected A. You have learned before when you were in grade 9, keep the steel point on A, draw an arc. It is like just 90 degree. Draw an arc, don't change the radius, keep the steel point on the next point, draw an arc. Here we found another point, just join and see 2 points A and the new point that we found. So that line is a perpendicular line to AB. Just as the same way, we can find any point. So I selected B. So construct a perpendicular line to AB from B. Take any radius, keep the steel point on B, draw an arc to intersect the line, don't change the radius, draw an arc to intersect the line. Just as earlier, keep the steel point on new point, construct an arc just as earlier. If you want, you can change the radius. Jump to the new point, draw an arc. We constructed two arcs, the two arcs joining, we got a new point. Here we found perpendicular line to this AB. We got two perpendicular lines now. Now we are going to construct parallel lines. Let's construct parallel lines to this AB on either side 3 centimeters away. So take your pair of compasses, keep the steel point on 0, using the help of ruler, measure 3 centimeters. Now keep the steel point on B, draw an arc to intersect that perpendicular lines. that line and arc intersect at a point that is 3 centimeters away. We can find another point on the other side. Just as same way, we can find 2 points 3 centimeters away from A. Here we found 4 points. Let us join 2 points. Hope you work with me. Here we have found 2 lines. You can measure the distance A to the line, that is 3 centimeters. If you take a correct measurement, that is 3 centimeters. So, mark 3 centimeters, 2 parallel lines 3 centimeters away from AB. Remember to mark parallel symbol. How can we mark parallel? How do I know parallel? Mark that arrow symbol. It represents that lines are parallel. Okay, let us go to the fourth one. Constructing the locus of a point moving at an equal distance from 2 intersecting straight lines. Let us see what this is. 2 straight lines AB and CD intersect at P. Let us see. Each and every point moves equidistant to DC and AB. So, what is this, children? That path, that locus is the angle bisector. Not only one angle bisector, we can find 2 angle bisectors. When we consider this acute angle, we got 1 angle bisector. When we got this obtuse angle, another angle bisector. So, locus of a point moving at a constant distance from 2 lines, that will be the bisector of the angle at P. We got 2 angle bisectors. Let us construct bisector of the angles. Before construct, let us see bisector of the angle. The locus of a point moving at an equal distance from 2 intersecting straight lines is a bisector of the angle formed at the intersection point of the lines. Let us construct bisector of the angle or angle bisector. Here you can see AB and BC, 2 lines intersect at B. The common vertex is B. Keep the steel point on B, draw an arc to intersect AB as well as BC. Here we found 2 points. Take any radius, keep the steel point on that new point, draw an arc. Just as the same way, don't change the radius, keep the steel point on new point, draw an arc. 2 arcs intersect at a point. Now, here we found a new point, join B and the new point. That is the bisector of the angle B, or that is the angle bisector of ABC. So, how do we call that is an angle bisector? We have to show these 2 angles are equal. You have to use same symbol. So, I have used AA. You also can try another symbol and represent that 2 angles are equal. At the moment, we learn 4 basic loci. What is the first basic loci? Locus of a point moving at a constant distance from a fixed point is a circle. Second one, locus of a point moving equidistant to 2 points. What is that? That is the perpendicular bisector. What is the third locus that we learn? Locus of a point moving at a constant distance from a line. That is a parallel line. What is the fourth one that we have learned? Locus of a point moving equidistant to intersecting 2 straight lines. That is the angle bisector. Right, let's try some problems now. This is the first problem. If the maximum distance between a cow and a tree to which the cow has been tied with a rope is 5 meters, construct the path along which the cow can travel such that the distance between the tree and the cow will be at its maximum. So, read that carefully. There is a cow has been tied with a rope with 5 meters. Construct a path along which the cow can travel such that distance between the tree and the cow will be at its maximum. So, this cow tied with a rope is 5 meters. That means that cow can move, maximum distance will be 5 meters. There is a tree, distance between a cow and the tree which the cow has been tied with a rope is 5 meters. So, this rope tied with a cow and a tree. So, using the loci and construction, you have to find this locus. Let's see how to find it. So, there is a point as tree. So, you have to mark a point as tree. There is a distance 5 meters. 5 meters away from the tree. So, the maximum distance that cow can move 5 meters. So, that means can be the first locus we learn. Let's try. Tree 5 meters away from the tree. So, what is this locus? That is a circle. Let's try this construction now. Get ready with your pencil, ruler and pair of compasses. Mark any point as tree. Keep the steel point on that point. You can take any radius because we can't take 5 meters. But remember to mark the radius. So, the maximum distance is 5 meters. So, radius is 5 meters. Hope you have done with me. Let's try another question. PQ is a straight line segment of length 5 centimeter. PQ is a straight line segment with the length 5 centimeter. A point X is placed 4 centimeters away from P and 5 centimeters away from Q. Find the positions of X by using the relevant constructions. Read the question carefully. not just a point. It says PQ straight line. This time we need to construct a straight line with the length 5 centimeter. Next, we have to find a locus 4 centimeters away from P. Another one 5 centimeters away from Q. Okay, let's start the construction. First, we need PQ line, or we call PQ line segment. Using the help of ruler and pair of compasses, you can construct PQ line segment. Next, let's find the locus. 4 centimeters away from P. So that is a circle. Radius is 4 centimeters. Remember to mark the radius as 4 centimeters. Right. Next we want another locus 5 centimeters away from Q. Let's measure 5 centimeter and take the radius as 5 centimeter. That is the locus 5 centimeters away from Q. Keep the steel point on Q. Construct a circle. Let's mark that radius as 5 centimeters. Right. Children, can you find the x? There are two intersecting points. Equidistance to, there are 2 points 4 centimeters away from P, 5 centimeters away from Q. So this is 1 point and this is 1 point. See that this point 4 centimeters away from P, 5 centimeters away from Q. See this point also 4 centimeters away from P, 5 centimeters away from Q. So we found 2 places. Let's try third problem. 3 houses are located in 3 places as P, Q and R. Which houses are not located on the same line? A common lamp post has to be located equidistant from these 3 houses in order to provide lights for all 3 houses. Using your loci and construction knowledge, find where to fix the lamp post as L. Read that question carefully. 3 houses are there, P, Q, R. They are not on the same line. There is a common lamp post equidistant to P, Q as well as R. Let's see, there are 3 houses, P, Q and R. They are not located, they are on the same line, P, Q, R, 3 houses. These 3 points lie on a triangle. There should be a place equidistant to P as well as Q as well as R. That means somewhere equidistant to P as well as Q as well as R. Now use your construction knowledge to find this place where to locate the lamp post. It should be equidistant to P and Q. That means somewhere on perpendicular bisector of PQ. Even it should be equidistant to P and R. That means somewhere on the perpendicular bisector of PR. Equidistant to RQ. That means somewhere perpendicular bisector of RQ. So these three bisectors, these three perpendicular bisectors intersect at a point. So that should be the location. Let's find the location. So let's join that PQ as well as PR as well as RQ. After that, we can construct locus of a point equidistant to P and R. That means perpendicular bisector of PR. Next, we can construct perpendicular bisector of, first we can construct perpendicular bisector of P and Q. Or even if you want, you can construct P and R. Or you can construct R and Q. So let's construct first locus of a point moving equidistant to P and R. Let's construct locus of a point moving equidistant to P and Q. So that means we need to construct perpendicular bisector of PQ. Next, you don't want to construct both perpendicular lines PR as well as you don't want to construct perpendicular bisector of PR as well as RQ. You only want to construct one perpendicular bisector. Now get ready with me. Let's try to find the location of the lamp post. Using your construction knowledge, let's find the place where to fix the lamp post. First, you can keep any place PQR, 3 houses, construct 2 perpendicular bisectors of any 2 lines. So first I will select PQ line, the house P and house Q equidistant to P house as well as equidistant to Q house. Just as earlier, you can construct 2 arcs that intersecting that 2 points. Joining, we can find perpendicular bisector. Somewhere on this line, there should be a lamp post because equidistant to P and Q. So how do we show that is a perpendicular bisector? Remember to mark equal as well as 90. Let's construct another perpendicular bisector. You can select either PR or RQ. So I will select PR. Just as earlier, keep the steel point on P. Take more than half of PR. Construct 2 arcs on either sides. Don't change the radius. Keep the steel point on R. Here we found that 2 points. Let's join that 2 points. take the help of ruler and join the 2 points. Here we have found the perpendicular bisector of PR. So, how do I know that is a perpendicular bisector? I have to mark perpendicular as well as that 2 P to the perpendicular bisector, that lines are equal. Remember to mark that perpendicular bisector 90 as well as equal. Next, see, can we find that place? We can't find that place. So, let's produce this line. Now, here we found the place. We can fix the lamp post. So, remember to mark L. Let's see that question, my children. P and Q, 2 houses. Equidistance to P and Q, that is the perpendicular bisector of joining that PQ. Next, we want to find the equidistant path or locus P and R. Why I selected P and R? If equidistant to P and Q, only P and Q. But we want to find the next house. Equidistant to P and R, this is the locus. Now, there is a common place, this is the common place. That is the common place that satisfied both conditions. Equidistant to P and Q, this locus. Equidistance to P and R, this locus. Equidistance to P, Q as equidistance to P, Q and R, that is the point L. Right. Let's go to the 4th problem. PQRS is a rectangular shaped land with the length PQ 80 meters and PS 50 meters. There is a treasure located 50 meters away from Q and equidistance to RS boundary and PS boundary. Mark where the treasure as point T by constructing necessary lines. Read this question carefully. There is a rectangle PQRS. PQRS is a rectangular shaped land with the length PQ is the length 80 meters, PS is the breadth 50 meters. There is a treasure located 50 meters away from Q, a constant distance from a point 50 meters away from Q. There is a point. Next says equidistance to RS boundary and PS boundary. RS not just a point, not 2 points, it is about a line, RS boundary. But not only one line, 2 lines, RS boundary and PS boundary, 2 lines. So, what is the common point S? So, that can be the angle bisector. Mark where the treasure as point T by constructing necessary lines. After read this question, you can sketch this. PQRS is a rectangular shaped land. PQ is 80 meters. PS is 50 meters. Somewhere there is a treasure. So, using your construction knowledge, we have to find this. Using the construction lesson, let's find the treasure place. PQRS is a rectangle. PQ is 80 meters, PS is 50 meters. the treasure located 50 meters away from Q. So, we can't measure 50 meters, but we know that PS and RQ are equal lengths because they are breadths. So, take the point Q as a center. You can draw a whole circle or an arc. That is the first condition given. Now, second condition, it says the treasure located equidistant to RS as well as PS. I told you earlier, S is the common vertex. So, we have to bisect S. We have to bisect the angle PSR. Keep the steel point on S. Draw an arc to intersect that two lines. Here we got 2 points. RS intersect at a point, arc and a line, there is a point. If you want, you can change the radius. Keep the steel point on that point. Draw an arc. Don't change the radius. Keep the steel point on new point. Draw an arc to intersect the earlier arc. Still we can't find a place. So, keep the steel point on correctly. Draw an arc. Now, here we found that new point. Let's join this S and the new point. So, that is the angle bisector of PSR. We found two loci. This is the second one we found, this is the first one we found. So, the angle bisector of S, remember to mark that two angles are equal. Even remember to mark radius. Now, both conditions satisfied one point. This is the place where the treasure located. So, mark that point as T. Children, look at this question. We have taken a circle and an angle bisector. So, the both conditions satisfied. There was a one place that is T. And how we taken that circle? We don't want to measure centimeters. By taking the data, that is 50 meters. So, this one is 50 meters. PS is 50 meters. So, QR also 50 meters. So, remember to mark 50 meters. So, the radius of the whole circle or this arc 50 meters. And the next, angle bisector. Without marking these equal symbols, how do I know that is an angle bisector? Remember to mark this A as well as this A, or you can mark any symbol. I have marked AA, you can mark any two symbols to show that these two angles are equal. So, we have used construction knowledge to find this treasure. First, we construct locus of a point equidistant to Q. That is a circle, but we want to construct part of the circle or arc because treasure located inside. Next, to find the treasure, there is another condition. locus of a point moving constant distance from PS as well as SR, because it says the treasure located equidistant to PS as well as RS. So, that means common vertex is S. So, we have to construct angle bisector. So, after marking angle bisector, remember to mark these two symbols A and A. If you want, you can use any other symbol to show that these two angles are equal. After that, you have to think about this is the first locus that we found and this is the next locus we found. Both satisfying, that is the point. Remember to mark the treasure place. So, where the treasure located, this is the point, mark that point as T. Children, today we have learned what is a locus, loci, 4 basic loci. What is a locus? It is a path. It is a path of a point moving according to geometrical law, that is a locus. Next we learn 4 basic loci. What is the first basic locus we learn? That is the circle. Locus of a point moving at a constant distance from a fixed point is a circle. Second one. What is the second locus we learn? That is the perpendicular bisector. Locus of a point moving constant distance from two fixed points, equidistant to two fixed points. That is the perpendicular bisector of joining the 2 points. Next we learn third locus. What is the third locus? That is the parallel line, not a point, not the 2 points, it's about line. Locus of a point moving constant distance from a line. Locus of a point moving constant distance from a line. So, what is that, children? That is a parallel line, not a parallel line. 2 parallel lines on either side of given two either side of given straight line. Next we learn what is the fourth locus, that is the angle bisector. What is the angle bisector? Locus of a point moving constant distance from given two lines. Locus of a point moving equidistant to given two straight lines. That two straight lines should be intersect at a point. So, locus of a point moving at an equal distance to given intersecting straight lines is the angle bisector. So, we have learned 4 basic loci: circle, perpendicular bisector, parallel line, angle bisector. Remember, if it is a point, construct circle. If you get 2 points, construct perpendicular bisector. If you get a line, construct parallel line. If you get 2 lines intersect at a point, you have to construct angle bisector. Today, at this moment, I have done 4 questions. There are so many questions in your textbook. Go through 28.1. You can practice more questions in your exercise 28.1. If you have any doubts, go through channel NIE in YouTube and you can follow this lesson again. Till we meet again, goodbye children.